So good morning. So again we are going to continue our discussion as far as the third chapter, an important chapter, and also still complication you have to understand. That is the effects of current. Actually general meaning is effects of current. In this effect we are going to see about the thermal effect or heating effect of current, and also chemical effect, thermoelectricity and the magnetic effect of current, and we will see as usual some problems. So this is a procedure. So in this chapter first we have to discuss about the thermal effect of current. What is the thermal effect of current? Whenever there is a heat, automatically current can be developed. That is also possible. Why it is happening? The energy conservation in an electrical circuit. In electrical circuit, any electrical circuit, even if a ceiling fan running for an hour or 10 minutes, 15 minutes, then we can touch the fan, we can feel heat. So this is one effect. So whenever the current flowing through any conductor, automatically heat is developed. That is also possible in the electric heater, iron box, water storage heater, whatever may be the thing, you can convert the current into heat. Why it is happening? What is the principle here? Suppose I take a device, AC is a device, any device, fan or electric heater, iron box or even AC, whatever may be the device AC, that should be connected to a battery. What happened? If B, the potential difference between A and C. What is a potential difference developed? So we know whenever the current flowing through a conductor, automatically potential difference developed. Here the potential difference developed is V, let it be. Q, when the potential difference develop, automatically the charge decreases by QV, potential energy of a charge. What is potential energy? Here energy stored because of potential difference, the energy will be there. The potential energy also decreases by QV. Here, what is my point is, here the energy is Q into V. Don't forget it, it's an important formula. The energy U is equal to Q into V. This energy is converted into some other form. Because such a energy is decreased means, according to conservation principle, energy can neither be created nor be destroyed. Here energy decreases. How much energy decreases may be converted into heat energy. That is a principle here. That is the heat in the resistor, mechanical work done by the motor. What is a motor? I already told you that electrical energy converted into mechanical energy. When motor is rotated, so kindly touch the mixer or grinder, we can feel the heat. And the chemical energy in a battery. So take a battery, we are having electrolyte, the chemical energy, that is also the storage battery gets heated. Everything we know. The energy is converted into form. My point is, the energy Q into V, charge into V will be energy. So, U is equal to VQ. You know, just now we have shown. But according to definition of second unit, what is the current value? I is equal to Q by T. You know, I is equal to Q by T. Therefore, Q is equal to I into T. Therefore, this Q can be replaced by IT. So instead of VQ, VIT, the energy formula VIT. That is a thing you have to understand. Because the energy U or E, we can take VIT. So general formula we know VQ, just now I have seen. This is the energy. So that means the energy will be there. That is the energy developed. So here, the energy VIT. This energy is nothing but a work done. This work done is stored as energy. Therefore, this how much heat is developed because, so usually 1 calorie of heat developed by the energy 4.2 joule. Generally the formula we know 1 calorie heat will produce an energy of 4.2 joule or 4.18. The correct value 4.18. We can round it at 4.2 joule. Therefore, how much heat is developed? V80 by 4.2. So, this one done is told as energy. Therefore, heat energy developed is simply V80 by 4.2 calorie heat is produced. Also, we know energy formula also I squared RT. Why? Because instead of V is equal to IR. IR is equal to I squared RT. Or sometime E is equal to V squared by R into T. This is an important formula. Most of the problem as far as your 12th entrance examination is concerned, V squared by R into T. So there are three formulas you have to keep in your mind. Number one is U is equal to VQ. That can be modified as VIT, also modified as I squared RT, also modified as V squared by RT. That should be divided by 4.2 calories. Such amount of heat is developed. So how much heat is developed means that the energy divided by 4.2, because 1 calorie of heat is produced by the energy of 4.2 joule. This is the energy conservation as far as the thing is concerned. So this is given in the formula. Then what is a power? So just like work done, what is the power? The work done in unit time. That means work divided by time will give power. Therefore, I should divide it by time. If the answer comes with T, that is called work done or energy. The energy stored as a power means the rate of doing work is called power. Therefore, simply VI, I squared R or V squared by R. This energy appears as heat energy called Joule's heat. Just now I told. The accelerating free electrons collide frequently. So we know metals are one in which free electrons are more. What are free electrons? Electrons which are not bound to atom are called free electrons. If they are free, they are in random motion. Therefore, they collide with one another, with the ions in the metal, and lost their kinetic energy, which appears as heat energy. So that there is a concept. If a motor is connected in the circuit, for example, take a motor, separately the motor runs, that is different. The battery separately reduces voltage, that is different. If it is connected to electrical circuit, then back EMF developed. If it is a motor, there is a back EMF is developed. This is central syllabus. Developed. What is a back EMF? I is equal to V by R, the same formula. So since back EMF developed, we have to subtract V minus V back by R. Simply, we know Ohm's law, I is equal to V by R. Instead, if a motor separately is there, the current is V by R. If the motor is connected in the circuit, then back EMF developed. Therefore, we have to subtract the back EMF from the voltage. Therefore, V minus V back by R. Therefore, what is the energy? VI. It is called VI, that is a power. VIT energy. VI is called power. Power developed is V into I. Therefore, V back into I plus I squared R. This is the total power. V back I. Mechanical power output of the motor. What is V? Because when the motor is connected in the circuit, what is the mechanical power output? That is V back into I. In a storage battery of EMF E is connected in the circuit. What is a storage battery? A battery in the your two-wheeler or four-wheeler, whatever may be the battery, that battery is called storage battery. So if you purchase a battery, it is connected to the voltmeter, directly we can see the 12 volt battery is there. That is called storage battery. That is value is called E. Therefore, power stored as usual V into I or here E into I. Therefore, the same formula is modified as V into I is equal to, we have to add EI plus V back I plus I squared R. If the storage battery is there, this we have to add the next thing. What is kilowatt hour? The kilowatt hour is the commercial unit. Why we are saying commercial unit? Somebody the question is asked usually. if the fan is running with the regulator 1. If the regulator is 1, the rotation of the fan is slower. If the regulator is increased to 2, 3 or 4th position, automatically the speed of the fan will be increased. Who will consume more current? That is a usual question in the entrance examination. If anybody uses the fan by putting a regulator in lowest resistor, that may be 1. Another man always using his fan by putting the rheostat with the 5. Therefore, the fan will rotate very fastly. Who will pay the more current? The confused question. Immediately the answer flash in our mind is those who are using the fan by 5. Therefore, the fan gets rotated very fastly. Therefore, it consumes more current so that he has to pay more pay or more bill. That is not so. That is not correct. As per the physics, according to the concept, both of them will pay the same amount. What is the reason? Because we are paying money for only power, not for current. That is, we have to keep in mind. In our houses or domestic purpose or any places, they are sending current in the form of power. So if there is a current cut, we should not say as power, as current cut. Why? That is wrong. We are not getting any current. We are getting only power. The correct word is power cut. Therefore, we are paying money only for electrical power consumption. So in order to rotate the fan, the minimum power it requires V into I or V into Q. We know that is a power, or I squared R or V squared by R. Such a power is necessary. So whether the fan is in the position of first position in the rheostat or 5th position, it consumes the power is same. So we are paying money only for power. Therefore, both are paying the same amount. So in which way we are paying the amount? So we have to calculate the power consumption. For the power consumption for the domestic purpose or any commercial purpose, we are calculating the power in terms of the unit called kilowatt hour. What is watt? Unit of power. Everyone knows. Not only electrical power, whatever may be the generally the unit of power is watt. We know the unit of power is watt. If it is multiplied by 1000, then it is called kilowatt. If anybody consumes 1000 watts power for 1 hour, that is called kilowatt hour. So kilowatt hour, what is the meaning of kilowatt hour? Anybody consumes the power of 1000 watts for 1 unit or 1 hour is called kilowatt hour. So technically this 1 kilowatt hour is equal to 1 unit. If anybody consumes 10,000 watts for 1 hour, 10 unit. Like that we have to multiply so that it is called commercial unit. 1 kilowatt hour actually is equal to how much energy it's consumed. 3.6 into 10 power 6 joules of energy consumed. So 1 kilowatt hour, how much energy in terms of energy? That is 3.6 into 10 power 6 joule. 1 kilowatt hour is equal to 3.6 into 10 power 6 joule. That is a conversion factor we have to keep. Then ratio of power consumed in two resistors in series and parallel. Power consumed, this is a very important thing. If I consider the two resistors, if these two resistors connected in series to a battery, this resistance R1, this resistance R2, this voltage U. Actually the current is always flowing from higher potential to higher. What is the concept here? I is the current flowing through the resistors. What is the current flowing through the resistor 1 or I1? I simply. For resistor 2 also I. I already discussed in the previous lessons. Whenever the circuit which are in series connection, the current is common. Therefore, the power of 1 is equal to simply I squared into R1. What is power 2? that is I squared R2. Why I took this formula? Because current must be the same, so that I took this formula. Then ratio of the power P1 by P2 is equal to I squared R1 by I squared R2. This I squared getting cancels. Therefore, P1 by P2 is equal to simply R1 by R2. This is a power ratio when two resistors connected in series. If two resistors R1 and R2 are given, simply find the ratio, that will give the power ratio. Therefore, P1 by P2 is equal to R1 by R2. This is the formula for the series connection. Suppose what happened? The two resistors in parallel. The similar circuit can be written. If two resistors connected in parallel to a battery, the same thing. This current goes here. So current is branched out, then coming out as I. So if I1 be the current through R1, I2 be the current through R2. What is the concept here? If they are connected in parallel, the potential difference will be the same. So here potential difference will be the same. Therefore, I take the formula P is equal to V squared by R1. This formula I have to take. What is P2? Similarly, V squared by R2. The same thing we have to find out. Therefore, P1 by P2. PV getting cancels. R2 by R1. So, if R1 by R2 comes, that is a resistor in series. If R2 by R1 comes, resistors in parallel. What does it mean? Power is inversely proportional. For more resistor, we are getting less power consumption. If it is a less resistor, more power consumption. That is a parallel connection, series connection. So this is given here. P1 by P2 is equal to R1 by R2. Similarly, P1 by P2 is equal to R2 by R1. This is an important thing. In any electrical installation, all the appliances are connected in parallel. What is the reason? Anybody say? So in our household purpose or anything, all the electrical installation only in the parallel connection only. So in any storage system or any bulb or any electrical instrument, there is a word in the printer, 220 volt, 40 watts, 220 volt, 1000 watts, 220 volt, 500 watts. In all the things, the power may be differed. What about 220 volt? That is a common voltage. If any voltage is common, that connection is called parallel connection. Just I have told to you. Any thing is common, the voltage is called parallel connection. What is the advantage of the parallel connection? If any particular electrical instrument gets damaged or gets fused or any damage occurs, all other appliances are working without any distraction. If it is series, what happens? We know the serial set, the bulb and other thing enjoying. The serial set bulb and anything, if any one bulb gets fused, the entire bulb will off. So we have to search it out where the bulb gets fused. We have to replace the bulb, then only the circuit will be completed. And also in domestic purpose, in all our household purposes, the parallel connection is more important because of this reason. Not only that, we can separately use. If we want to room light gets on, we can on and off. So particular instrument can be operated by the off position of all other instruments. If it is connected in series, what happens? If we on one instrument, automatically other instruments get started. That is a problem. These are the problem. So that in all the domestic installation, all the items are insulated only in the parallel connection. So that is the advantage. What is rating? How much the power you are using? How much the amount you have to pay? That is called rating. The electrical appliance, its rating is specified as, in any bulb, I already told you that when you purchase a tungsten filament bulb, in the bulb it is printed power in watt, voltage in volt. So for example, 40 watts bulb, 220 volt. I already told you that all electrical appliances operated parallelly with the voltage of 220. So what is the voltage we are getting? 220 to 230, around about 220. In the 220 volt, how much power consumed by the appliance? The power consumed by the appliance is 40 watts. The 40 watts bulb continuously glowing for 10 hours, 400 watts. Then less than half unit. Like that we have to calculate it. So from this rating can be calculated because power R is equal to V square. Because just now I have seen the power formula V squared by R or R is equal to V squared by P. That is a formula I have given. The resistance. The maximum current that can be passed without the appliance getting fused. So we have to understand it, how much is the current, so that the voltage stabilizer we are using. What is the advantage of stabilizer? The stabilizer maintains the current. If it is more current, what happens? The instrument gets fused or instrument gets damaged. To avoid that, we have to calculate what is the maximum current. How can we calculate? We know power is equal to V and I. Therefore, I is equal to power by volt. So volt is always 220. What is the power? So suppose 2200 watts power for AC. If the voltage always 220, getting cancels 10 watts. That is a 10 ampere current. The maximum current can be possible to go through the AC alternating. That is an air conditioner. So when you use an ampere or a meter, we can check whether 9.5 to 10 volt. We are getting the ton, 1.5 ton AC. We are purchasing. What is the meaning of that? Without knowing anything, we are purchasing 2 ton AC, 1.5 ton AC. What is the thing? What is the power consumed? The power consumed by the particular instrument in terms of ton. We know ton is equal to 1000 kilo. That is a thing. That is a watt. In terms of another thing, it is a watt. That is 2200 watts. If it is an power consumed by the particular AC, that should be divided by voltage 220. Then what is the current? The maximum current can be flow through such an instrument is 10 ampere. So more than 10 ampere what happen? The instrument gets damaged or gets fused. So that the stabilizer always maintained. We cannot make the value of or change the value of power. That is a constant one. The voltage fluctuation will be there. So usually we are getting low voltage comes it is a very high voltage comes because of that particular voltage, the fluctuation current will be there. I squared R will be the power. Everything will be damaged. That is a formula. How much the rating, for finding rating, what is the resistance? V squared by P. What is the maximum current can possible through a particular instrument? P by V. These are the formula we have to keep your mind. Otherwise, it is not possible. These are the things. Are you clear now? That is a power. Very first problem itself, the power consumption. So we have to understand it. Everything. So 1:x is the ratio. Then what is the power consumption? Usually the question is asked, the two resistors having the ratio 1:x. That means R1 is to R2 is equal to 1:x. If they are connected in series, what is the power ratio? We know P1 by P2 is equal to R1 by R2. That is 1/x is the answer. Usually the question is asked. If the two resistors connected in parallel, what happened? P1 by P2 is equal to R2 by R1. That is x by 1. So if answer is 1 by x, then they are connected in series. If answer x by 1, they are connected in parallel. Like that, there are so many problems asked in the ratio of power consumption. That is electric heater, everything it is coming. Be careful. Then we can pass on to thermoelectricity. Now thermoelectricity is actually a reverse thing. Whenever the current flowing through the coil, heat is produced. Whenever there is a temperature difference, current is produced. That electricity is called thermoelectricity. We are getting electric current in terms of temperature or by means of heat difference. We can have the current. This was first given by the scientist Seebeck. Then the effect is called the Seebeck effect. Seebeck actually take two dissimilar metals. I take a two dissimilar metal. One metal is copper, another metal is ferrous. If they are kept in a two different junctions, one is cold junction, another is called hot junction. So if it is connected to the galvanometer, after some time the galvanometer deflects. So this effect is called Seebeck effect. What is Seebeck effect? To the junctions of two dissimilar metal, the junction, this is called cold junction, this is called hot junction. The junctions of two dissimilar metals are kept at a different temperature. EMF acts, known as Seebeck effect. My question is, why we are taking two different metals? Even a single metal is not possible. What is the reason? So, if both are same metal, what happens? The free electrons will be the same. We are not having any excess electron. For the current production, we need electron. So, if both are in the same metal, what happens? We are not having excess electron. And also, why we are having the different temperature? We know whenever the heat is there, electrons are always traveling from higher temperature to lower temperature. Automatically, when the hot junction, very high temperature, therefore the electron flow. There is a flow of electron that causes the current. That is called Seebeck effect. In the Seebeck effect, we have to understand so many ideas here. If two wires of different metals, why we are taking different metal? Just now we have discussed. Are joined at the ends and two junctions, it is not functions, two junctions, JU. The two junctions are maintained at a different temperature, then the current starts flowing through the wire. EMF developed is called the thermo EMF and the current is called thermoelectric current. The two dissimilar metals connected in this way is called thermocouple. Here the cold junction, it is reversible in the, if the circuit is reversed or current direction is reversed, thermocouple. It is reversible in that if hot and cold junctions are interchanged, I put a hot junction here and a cold junction here. If the hot and cold junctions are reversed, then the current direction is also reversed. EMF, the value of EMF is very low value in the volt of few microvolt. That is few microvolt or millivolt per degree temperature. Very low value, keep your mind. It is in the order of millivolt or microvolt. Thermoelectric series. What is a series? Seebeck actually did so many experiments with the available metals with him. First he paired one by one. He attained a following result and arranged the metals in the form of a particular series called thermoelectric series. This was designed by the scientist Seebeck after the invention of Seebeck effect. What those series? The series actually starts with antimony, ends with bismuth. In between all the elements are there. He did. And they arranged in a sequence. Starts with antimony and bismuth. What is the result, experimental result he got? Current flow through the cold junction from the metal which appears earlier in the series to later. For example, I take antimony and ferrous. Which is earlier? Antimony is earlier. Therefore, the current direction, metal which appears earlier in the series, from antimony to ferrous, only the current flows. If you are taking, I give an example, copper and iron. So, iron, first element, copper, latest, next. Therefore, the current is always flowing from ferrous to copper. That is understanding. Current flows through the cold junction from the metal which appears earlier in the series to later. Cold junction. We have to put a arrow diagram only from the cold junction. Be careful. So the cold junction, the arrow mark From where to where? From the metal appears in the first to the metal appears in the next. The another thing, the longest or greatest the separation, greater is the thermo EMF generated. Here the EMF is produced or generated. What is the meaning? So instead of antimony and ferrous, we are taking two metals, we are getting some amount of thermo EMF. Instead of that, antimony and zinc, we are taking the more thermo EMF. What is the maximum separation? Antimony and bismuth. If you are taking antimony and bismuth are the two dissimilar metals, the maximum value of thermo EMF developed. That is the reason. The 2 point you have to keep your mind. According to thermoelectric series, the current direction is always from the metal appear in the first to the metal appear in the last, that too in the cold junction. The longer the gap, more will be the EMF. That is the thing you have to understand it. This variation of thermo EMF with temperature difference, this is also very important for your discussion. So I take a junction, one junction at a higher temperature, another junction at a lower temperature. There is a temperature difference. So in order to calculation simple, very simple for understanding, I keep the cold junction as 0 degree. The hot junction temperature increases by 10 by 10. First I keep 50 degree, the cold junction is 10 degree, so 0 degree. What is the temperature difference? 50. What is the thermo EMF? One reading. Again, the temperature of the hot junction increases 60 degree. Then what is the temperature difference? 60. Again we have to find the thermo EMF, second reading. Like that every 10 degree rise, what is the temperature difference? I take the temperature difference in the x-axis. The temperature difference. So since I put a 0 as cold junction, we can put the temperature of the hot junction directly here. Otherwise, if we are keeping the cold junction for some other temperature, we have to subtract it, then we have to put. And the thermo EMF in the y-axis. A graph as shown in the figure is done. What does it mean? It means very easily, when the temperature difference increases, thermo EMF also increases. Kindly go through the graph. Whenever the temperature difference increases, thermo EMF also increases, reaches the maximum value for a particular temperature difference called neutral temperature. The thermo EMF is maximum. For a particular temperature difference, the thermo EMF is maximum. The temperature difference is called neutral temperature. If you increase the temperature difference beyond the neutral temperature, what happens? The thermo EMF starts to decrease. At a particular temperature difference, thermo EMF becomes 0. This temperature difference is called temperature of inversion. So you have to keep your mind, there are two temperatures, just I have noted. Number one is neutral temperature, another one is called inversion temperature or temperature of inversion. Why we are saying it is called temperature of inversion? If the temperature difference beyond this value, the graph comes in the negative. This is a positive, negative. Therefore, it actually inverted the positive thermo EMF to negative thermo EMF. So, it is called inversion temperature. Usually, what is the relation between these two? That is also I want to discuss. That is not in the slide. Usually, the inversion temperature is more. As per the graph, it is 2 times Tn. When if temperature of the cold junction is equal to 0, so I put the temperature of cold junction as 0, then neutral temperature or inversion temperature is 2 times the neutral temperature. Instead of that, how can you change now? So suppose cold junction value given, then the formula is modified as Ti is equal to 2 times Tn minus Tc, or 2 times Tn is equal to Ti plus Tc. What is Ti? Inversion temperature. What is T? Temperature of cold junction. If we take 0, we can directly put Ti is equal to 2 Tn or Tn is equal to Ti by 2. Both are same. If any problem, the temperature of the cold junction value is given, we have to modify the formula. Ti is equal to 2 Tn minus Tc. or 2Tn Ti plus Tc, from which the neutral temperature can be calculated. Therefore, Ti plus Tc whole divided by 2. This is the formula. This is the one way. So another way, just now I have given in the thermo EMF developed can be related by the formula alpha T plus 1 by 2 beta T square. This is central syllabus. Be careful. V. What is the thermo EMF developed? Generally, thermo EMF V is nothing but the difference in temperature, difference in thermo EMF between the two junctions. That is temperature of the hot junction minus potential developed in the cold junction. That is the value of V. This V can be calculated by using the formula alpha T plus half beta T square, where alpha and beta are constant. Alpha T plus half beta T square. From which also the neutral temperature can be S-plane. That is the thing how to understand it. How? That is given in the slide. Then what is called Seebeck coefficient? Seebeck coefficient, yes, is nothing but the rate of change of thermo EMF is called Seebeck coefficient. In our 12th standard book, we are not having Seebeck coefficient. We are having only Peltier and Thomson coefficient. What is Seebeck coefficient? Seebeck coefficient nothing but the rate of change of thermo EMF will give the Seebeck coefficient. That is the thing we have to understand it. Therefore, we know V is equal to alpha T plus half beta T square. So, from the graphical value, we know for neutral temperature, the thermo EMF value is maximum. That is a point to be noted. So, when the temperature reaches the neutral temperature, the thermo EMF value is maximum. Be careful. So, suppose I have to differentiate this equation, what happens? This equation may be differentiated with respect to time, because dV by dt is called here. So, alpha plus half beta into 2t. So, 2 getting cancels. Therefore, the answer becomes alpha plus beta t. This is the answer. For neutral temperature, if T become Tn, V is a constant value. Therefore, the rate of change of constant value become 0. Therefore, alpha plus Tn is equal to 0. Alpha plus beta Tn is equal to 0. Or beta Tn is equal to minus alpha, or Tn is equal to minus alpha by beta. This is the formula for neutral temperature. So, if in any problem, if value of constants are given, alpha and beta value are given, simply substitute it, we can able to find out the neutral temperature. Otherwise, I have given in the previous board, we can use that formula. That means Ti is equal to 2 times Tn. If Tc is equal to 0, or Ti is equal to 2 times Tn minus Tc. If temperature of the cold junction value will be given. Substitute this, we can able to form. So this is the thing we have to understand. This is given in this thing. The rate of change of thermo EMF with the temperature S. Or S is equal to dV by dt alpha plus beta when T become Tn. When the temperature become neutral temperature, from the graph V is maximum. Differential of maximum value 0. Therefore, alpha plus beta Tn is equal to 0, or Tn is equal to minus alpha by beta. This is the thing we have to understand it. That is the important thing from Seebeck effect. So another effect is called Peltier effect. The Peltier effect actually converse of Seebeck effect. What is the Seebeck effect? In the Seebeck effect, we are having two dissimilar metals, and the junction may be maintained at a different temperature. What is the Peltier effect? Here also we are having two different metals, but we are not maintaining the temperature. A current, we are sending the current through the thermocouple. If the current value or current is passing through the junction, at one junction heat may be evolved, At the another junction, heat may be absorbed. That is a thing we have to understand it. At one junction, heat may be evolved. At another junction, heat may be absorbed. That is called Seebeck effect. That is a Peltier effect. The Seebeck effect, two dissimilar materials also there. The temperature, we have to maintain the temperature difference. What is here? Here the two dissimilar metals are there, through which the amount of current is passed. When the current is passed, automatically at one junction heat is evolved, hot junction. At another junction, heat may be absorbed, cold junction. So converse of Seebeck effect, if a current is passed through a junction of two dissimilar metals, heat is either absorbed or evolved at the junction, and reversing the direction of the current, the heat effect is also reversed. From it, what is a Peltier coefficient? Peltier coefficient is also just like a Seebeck coefficient. It is the amount of heat energy absorbed or evolved when 1 ampere current is flowing for 1 second. So, it is the amount of heat energy absorbed or evolved at a junction per second when a current of 1 ampere flowing through it. There is a value, the Peltier coefficient unit is volt. So, here also we have to find out the Peltier coefficient. Similarly, Thomson effect. The Thomson effect is entirely different. Even a single metal, so for Seebeck as well as the Peltier effect, there are two dissimilar metals are there. In Thomson effect, even a single metal heated unevenly, a current is flowing through it, heat may be evolved or absorbed throughout the body of the conductor. What do you think? Even a single metal heated unevenly, current is flowing through it, heat energy is evolved or absorbed throughout the body of the conductor. Some metals first heat evolved and then absorbed. In some other metal, heat absorbed and then evolved. That is positive Thomson effect. Another one is called negative Thomson effect. For example, ferrous, nickel, cobalt, negative Thomson effect. For silver, gold, copper, positive Thomson effect. Only one metal which doesn't have both positive as negative, that metal is called lead. Don't forget it, lead, L-E-A-D. The lead doesn't obey either positive or negative Thomson effect. So that we are using for fusing two wires in all electrical instrument or electronic instruments, we are using lead as a third metal. If we are using another metal, they may cause the hindrance of additional EMF. So only the lead alone has neither positive nor negative Thomson effect. So that we are using lead as a third metal we are introducing. Even though you are introducing a third metal, it doesn't affect. If you are introducing third temperature also, that affect the EMF. If you are introducing a third metal, that also affect the EMF. If you are using lead as a third metal, it won't affect the thermo EMF. That is the purpose we are using lead. So that is a thing. Then what is Thomson coefficient? The same definition. It is the amount of heat energy evolved or absorbed when 1 ampere current is flowing for 1 second, when the temperature difference becomes 1 degree centigrade. So that is a thing. If dV, potential difference between 2 points in a metal which have a temperature difference dt, then the ratio dV by dt is called Thomson coefficient. So just like dV by dt is called Seebeck coefficient, similarly Thomson coefficient dV by dt, that is equal to constant, the letter is sigma. The positive and negative Thomson effect, lead neither positive or negative. Applications: measurement of temperature, detection of heat radiation, thermopile. So even we are measuring very high temperature, more than two metals are seriously connected. If two dissimilar metals are connected, they are called thermocouple. More thermocouples are connected in series, they are called thermopile. That is used in the refrigeration. Even very small amount heat may be transmitted from lower temperature to higher temperature only by compression. By using very small current may be transmitted by using refrigeration. These are the uses of thermoelectricity. So with this we can complete today, and the next day we can pass on to the next day effect. Thank you.